in this problem, we have supposed that of all the adults in the U.S., the mean spending for Halloween is $50. So this makes me think for all of the adults, this must be a population mean. So my population mean, mu, is equal to 50. And the standard deviation is 35. So again, this is probably sigma standard deviation of my entire population. So that's for my population. Now we decide to take a sample of 100 adults. Okay, so that's our population. Okay, and then we're going to take a sample with n equals 100. And we want to look at the mean, so we want to look at our sample average. So we'll be interested in x bar. So first, what's the shape of the distribution of all the possible sample means? Well, we know thanks to our central limit theorem that if our original distribution is normally distributed or our sample size is at least 30, then the distribution for all of our possible sample means should also be, or should be normally distributed. So, because we have a big sample size, the sampling distribution for x bar should be approximately normal. Okay. So again, if we went through and picked out all the possible samples we could get, then for each sample we would get a sample mean. And so we'd have this entire list of possible sample means. And of that sample means, those are our sampling distribution. Is basically the distribution of all the possible sample means. And because the sample size is big, 100 is big, the shape should be approximately normal. For B, what will be the mean? So again, all of our possible sample means, that's just a big list of numbers. We can find the average of that, and it should be equal to the original mean of our population. So 50. For C, what will be the standard deviation? The standard deviation for all the possible sample means is equal to your original standard deviation of the population divided by the square root of n. So our standard deviation is 35, and the square root of 100 should give me 3.5. Now D, find the probability that the total spending for 100 people is greater than 5,700. Okay, this is a bit of a trick question because it's talking about total. We only know how to do things for sample means. So let's change a total to a sample mean. So if the total is 5,700 and n equals 100, then the sample mean, x bar, would have to be 5,700 out of 100, which gives me 57. So really, we're asking you to find the probability that our sample mean is at least 57. Actually, it says greater than, so just greater than. Now, that doesn't really matter for continuous distribution if I put greater than or greater than or equal to, but here we have probability that our sample mean is at least 57. Now, the way we do this is we think, okay, this is a normal distribution. Here's x bar equals 57. I want all the area to the right here. But we just put it straight into our calculator. We're going to use a normal CDF function, whatever that is on your calculator. And our specific value we're interested in is going to be 57. Okay. Most of our calculators had kind of a lower bound and an upper bound, so let's continue out here to like 1 billion or something. We'll just put in lots of zeros. So we'll do our lower bound of 57, our upper bound, some ridiculously big number with lots and lots of zeros. We'll do our mean of 50 and our standard deviation of 3.5 and put that into our calculator, and we will get, so the probability that our sample means at least 57, we should get 0.0228. So super easy, you just put it straight in a calculator. Now for part E, what's the cutoff to be in the lowest 20% of the possible sample means? So again, draw a picture every time is so helpful. We're saying, okay, we want to be in the lowest 20%, which means we have 0.2 here to the left, and we're looking for the x bar value that makes that possible. Okay, so in this case, most calculators will give you area to the left, although nowadays they'll also give you area to the right or center or whatever you might be interested in. But we want here, point to area to the left. So we'll use, because we know our probability and we want to find the x value instead, we'll use our inverse normal function in our calculator. And we'll do area to left equals 0.20. And again, we'll do our mean of 50 and a standard deviation of 3.5. So usually the hardest part here is to know what is the mean and what's the standard deviation. So because we're talking about sample means, we use our mean is 50, but you have to use that new standard deviation for 3.5. Okay, just again put this straight into your calculator and you'll get that x bar has to be 47.06. So to be in the lowest 20%, that means 20% of all of our possible sample means will be less than 47.06.